Hey gang, so it is time for our pre-test video for Unit 2. So without further ado, let's get going. Relations and functions. All right, so we're going to start off. I've got two graphs on here. Well, you know what? We'll label this graph 1 right here and 2. So on your dry erase board, I want you to put a 1 and a 2. Here's what I want you to tell me. 1 is it a function? Yes or no? And the second thing I want you to tell me is it discrete or is it continuous? And I'll write that down here. Discrete or continuous. And they might not both be the same thing. Continuous. So which one's discrete, which one's continuous? Are they both discrete or are they both continuous? Hold your board up so I can see it. Is it a function? Is it not? All right, so that's pretty awesome. I'm pretty sure you guys got that right. Obviously, discrete is distinct points. That would be graph 1. Continuous is I put my pencil down and I continually draw. That would be number 2. And when I do the vertical line test, that's not really vertical. I only touch graph 2 once, but over here on graph 1, look how many points I go through. So this one is not a function, and this one is a function. All right, raise your hand. What questions do you have? Moving on. Okay, so here we go. A, B, and C. Take a second and look at those. The question on the table is, oops, sorry about that. Is it a function? And that's the wrong red. There we go. Is it a function? So write A, B, and C on your board and circle the letters that show X as a function. F of X as a function. Hold your board up when you get it. Going to give you just another few seconds because I know there's a lot of numbers on here. All right, I'm going to start off with A. When I look at A, remember, I don't even care what the Y column says. I only care, are any of the X's repeating? They are not, so I'm going to say, yes, this is a function. Okay, I'm going to look at B. Do any of the X's repeat? I don't even care about the Y's. What do I notice? Right here and right here. Same number, same X. Therefore, that is not a function. No. All right. I don't care about the Y's. Do any of these X's repeat? They do not. So it's a yes. So on your board, you should have circled A and C. X out B. All right, what questions do you have on that one? Raise your hand, let me know. You're already thinking, I'm going to ace this test. All right, so here we go. You're going to tell me which is discrete. Now remember, the key word for discrete is we can count them. It's countable. I can count it. Continuous is measurable. I have to measure it. I can't count it. Okay? We're going to remember that as we look at this. Now, dogs in a kennel. Is it going to move under discrete or continuous? Am I counting the dogs or am I measuring the dogs? Yeah, of course, I am counting the dogs. That would be discrete. Okay, raise your hand. Ice in a glass. Who can tell me which way it goes? All right, hopefully that was enough time. Ice in a glass. I'm going to count the ice in the glass. All right, next one. Raise your hand if you can answer. Time spent shopping. Time is continuous. You measure the time. You're there for 2 or 3 hours. All right, a line on a graph. Now, if you're wondering, like, what does that look like? It would look like this. I'd have a graph, and I would have, let me find a pen, a line on it. Would that be continuous or discrete? Raise your hand, tell me. It would be continuous. All right, keys on the keyboard of a computer. What do y'all think? Discrete. I'm pretty sure y'all got 100 on that. All right, here we go. Clear your boards off. I'm going to give you a little bit to look at this one. We're going to say, is it a function? And we're going to say the domain and range. I'm going to give you about 30 seconds on this one. All right, is it a function? When I do the vertical line test, I only touch it in one spot, no matter where I draw the line. So therefore, yes, it is a function. All right, I'm noticing that I had to put my pencil down and draw. So that means it is continuous. If it is a continuous function, I have to have inequalities. And I need to figure out what are my boundaries. All right, so let's look at that. Domain is how wide does this graph get? Well, it comes all the way out to here and all the way out to here on how wide it is. So my boundaries are -5 and +9. So -5 is less than 9. Okay, that's pretty good, but do I actually physically equal -5 and 9? Do I go through those points? I sure do. So I need to make sure that over here I put my equals to underneath my inequalities. Okay, let's do the range. Range is how tall is it? Well, I'm doing continuous, so I need to make sure I put my inequality. Now let's take a look. How tall is this graph? Well, it goes all the way up here. And, oh, you know what? I only went halfway, didn't I? I'm going to fix that. We're going to pretend that it came all the way down to here before it came back up. And so it comes all the way down to here. So how tall does it get? Well, 1, 2, 3, 4, all the way up to 5. And 1, 2, 3, 4, all the way down to -4. Which one's smaller, -4 or 5? -4 up to 5. Do I physically equal them? Yeah, I go right through those points, so I need to put my equal sign. And I said it before, this would be a continuous function. All right, what questions do you have on that one? All right, on to the next one. Here we go. We're going to evaluate some functions. Okay, so when we go to evaluate, we need to remember that this is just a fancy way, f of x is, of saying y, right? If it's y equals, I can just plug it into my calculator. So y equals 2x plus 1. This over here, this is saying that's the numbers I want. So if I were to make a table, these are my x values, -2, 0, and 1. Can you fill out that table for me? All right, I'm going to fill it in. Show me your boards when you get it. -2 is going to be -3. 0 is going to be 1. And 1 is going to be 3. Simple as that. Now, could I have done the store feature on this? Absolutely. I could have stored x as -2 right here. I could have plugged this into my calculator, and I could have evaluated it. Would have worked either way. I just chose, since it was a simple, already solved for y, I'm just going to plug it in and go to the table on my calculator. All right, what questions do you have? All right, here we go. Let's look at the next one. Clear your boards. F of x equals 0, 1, 2, 1, 1, -3. What does f of 1 equal? Hold up your boards and let me know. All right, So remember, f of 1 is just being replaced by the x, right? I'm replacing x with 1. Which one of these shows x as 1? Yeah, that would be this one. So when I plug in 1 into my equation, the output is -3. So -3 would be what I'm missing. What questions do you have? We could try another one. Let me use a purple. If I gave you 1, 2, 3, 4, 5, 6, and I'll do 4, 3. So let's say here's my function. And I ask you, what is f of 4? So I want to know, when x is 4, what is my output? And you're like, oh, this one. Oops, sorry. You're like, this one? I'm like, no, 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 not that one. This one, when x is 4, y would be 3. There we go. All right, on to the next one. Clear off your boards. Here we go. Graph the following. 2x plus 3y equals 6 for that specific domain. Now, we had one like this in our homework that we did in class, but I'm not sure how many of you remember this one. That's why I chose to put this one on the pretest video. I'll do the graph at the end. Okay, so in order to graph this for that domain, really I need to figure out, I've got a t-bar here, and I need to do 0, 1, and 2. The problem is I cannot put that equation into my calculator. So I'm going to have to do it hand by hand, trial by trial. So here's what I'm going to do. I'm going to take 2x plus 3y equals 6. And I'm going to take the x, and I'm going to change the x to 0, because I'm going to plug this x, substitute it into my equation. All right, 2 times 0 is 0, plus 3y equals 6. I'm going to divide both sides by 3, and I'm going to get x, or y, equals what? 2. So that means when I plug in 0, I'm going to get 2. Okay, let's do the same thing again, but this time let's plug in 1. So I'm going to erase all this. You plug in 1 while I'm erasing. Instead of 0, I'm going to put a 1. Okay, 2 times 1 is 2, plus 3y equals 6. Well, I'm going to need to subtract 2 from both sides. 3y equals 4. I'm going to divide both sides by 3, and y is going to equal 4 over 3. So I'm going to come up here and put 4 over 3. Now, we don't normally get fractions, but that's okay. We can deal with them. All right, one more time. This time we're going to replace it with 2. So I'm going to erase this again. You start solving that next one. So I'm going to plug in 2. So that's 4 plus 3y equals 6. I'll subtract 4. 3y equals 2. Not a hard problem, but there is a lot of moving parts to it. Like, there's a lot of steps. That's okay. We can handle steps. Y equals 2/3. There it is. Okay, now the other thing it wanted me to do was to graph this. So I'm going to erase this. I'm going to graph it. It's going to draw some lines. And we will graph it. 0, 2 would be up here. 1 and 4/3, so that's a little bit higher. 2 and 2/3 would be about right there. And there we go. Now, it says to graph it for this domain. That means I'm not going to connect the dots because it only wanted me to graph those 3 points. So I'm not going to connect the dots on that one. All right. What questions do you have? Clear your boards. Oh, that's it. We're done. I don't think there's anything else. Not for my on-level pretest. All right, guys, thanks for watching and good luck.